We'll solve few problems based on the concept whatever we have learned. All right. Look at the first one. A black and a red dice are rolled. All right. First sub question. Find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in a 5. Correct. Second one, find the conditional probability of sum obtaining 8 given that the red die resulted in a number less than 4. Okay. Now, first thing is you need to understand the sample space, the total conditions as to what is there, what is not there. Correct. Then based on that, we can go for the next part. Fine. So let's solve this one. So we'll talk about 1A. See the sample space, it's going to be, here we have a black and a red, correct? Guys, it's just like saying two dice, that's all. Okay, black and red, they've given a color, but I mean, it makes no difference. It's just like two dice are there, so that's all. All right. So what we can write, maybe we can write it as, see, B1, correct? So when you write B1, likewise, the second one is going to be R1. See, the first black and the red. So this is going to be the first combination. Likewise, the second one is going to be B1, correct? And the second one is going to be red, R2. B1, R2. So on and so forth till the last one, which is B1 itself, but R is going to be 6. See, this is going to be the last one. Second case, it's going to be B2, R1, next B2, R2, so on and so forth. So till B6, R1, B6, R2, so on and so forth till B6, R6. B6, R6 is going to be the last one. Now we have 36 possibilities in total, isn't it? So this is the sample space, the total sample space. Now let's try to understand. See, here we are talking about conditional probability, correct? So what is P of A given B? P of A intersection B by P of B. Make sense? Okay. Now find the conditional probability of obtaining a sum greater than 9. So P of A is nothing but probability of sum greater than 9. See, if the sum has to be greater than 9, then what are the possibilities? So we can start by taking P of 5, 5. That means B5, R5. Correct? So 5 and 6. Next one. Next one. So you can start by taking 6 and 4, 6 and 5, 6 and 6. Correct? Of course, we have, see, if you look at 4 and 6 also, 4 plus 6 is also 10. So there are 6 possibilities. So we can say probability of this one is going to be 6 out of 36, which is 1 by 6. Right? Now P of B is what? Given that the black die resulted in a 5. Black die resulting in a 5 is what? 1, 2, 3, 4, 5, 6. It's basically B1, R1, sorry, B5, R1, B5, R2, B5, R3 till B5, R6, correct? So totally we are going to have 6 out of 36. That's 1 over 6. Makes sense? Now both of them, that is A intersection B, that is the sum has to be 9 and the black die has to be result in a 5. Okay, let me repeat again. What we are looking at that the sum should be greater than 9 provided the black die should result in a 5. Two possibilities, B5, R5, B5, R6, only two, correct? So we can say that P of A intersection B is going to be 2 out of 36. That's 1 out of 18. Now let's apply the formula and solve this one. P of A given B. P of A intersection B divided by P of B. So 1 by 18 or 1 by 6. Correct? So the answer is going to be 1 divided by 3. So probability that the sum is greater than 9 provided that the black die is going to give us 5 is 1 divided by 3. Very, very simple. Let's do the next one. Same way we'll do the B question. See, we have in B, likewise, same thing. Conditional probability of sum 8 given that the red die resulted in number less than 4. Alright. First let's do the sample space. Just like before, you know you are going to have 36 possibilities, correct? But here, when they say that the sum is equal to 8, so P of A is probability of sum is equal to 8. So what are the cases? Start by taking from 2. Okay, from 2. That is 2 comma 6. When you say 2 comma 6, black is 2 and then red is going to be 6. Isn't it? So 2 and 6. Then after that we can also take 3 and 5, 3 and 6. So we need to count, correct? Remember, the sum is equal to 8, isn't it? So 2 and 6, correct? Next 3 and 5, 3 and 6. Next 4 and 4. Oh, sum is equal to 8, isn't it? Yeah, so 2, 6, 3, 5. So 3, 6 will not come because 3 and 6 will give us a sum of 9, right? So 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. There are 5, correct? So we have probability of this one is going to give us 5 out of 36, right? The next one, P of B, the resulting die, a red die resulted in the number of 4. Okay, so we have P of red less than 4, correct? Which is nothing but the first column, second column, third column, isn't it? First, second and third column. If you look at 3 columns, that's 18 out of 36. So 18 out of 36 is nothing but 1 divided by 2. Now, what is the intersection? That is, you need to have the sum as 8 plus the number, the red die number should be lesser than 4. Correct? This is what we are looking at. So when you look at that one, so 1. See, you cannot have, okay, like if you write it like this, 2 comma 6, 6 comma 2, 3 comma 5, 5 comma 3, and 4 comma 4. The second number should be lesser than 4. Rule out, rule out, rule out. So we have 2. So probability of A intersection B is 2 out of 36. That's 1 out of 18. Now let's apply the formula and solve this one. We have P of A given B, P of A intersection B divided by P of B. Right? So intersection is 1 over 18 over P of B, which is 1 by 2. So answer is 1 by 9. So P of A given B is 1 by 9. So this is going to be the final answer. Fine. So this is the answer for 1A, 1B. Correct. Now let's do the next one. Look at the second one. A fair die is rolled. Consider the events. Okay, fine. They're asking you so many things. First, let's look at the sample space. Sample space is 1, 2, 3, 4, 5 and 6. Correct. So what is P of E? 3 out of 6. Half. Correct. And what is P of F? That's 2 out of 6. 1/3. And P of G, 4 out of 6. It's 2 by 3. Correct. Now let's do the first one. P of E given F, that's nothing but P of E intersection F divided by P of F. Correct. Or you can also take, instead of P of, you can also take N of this by N of this. Because to be honest, it's going to give you the same result. Okay, there is no change in the result whatsoever. So when we do n of e intersection f, n of e intersection f is just 1. That's number 3. Divided by n of f is 2. Correct? Second one. See, oh, sorry, not b. We have another part in this one, that is p of f given e. See, this will be p of f intersection e divided by p of e. That's 1 divided by p of e is 3. So 1 divided by 3. This is the answer for this one and this one. Alright, let's do the next one. P of e given g. That's nothing but n of e intersection g divided by n of g. Intersection of e and g. We have 3 and we have 5. So we have 2 of them divided by 4. Half. Like same way. P of g given e. That's going to be n of g intersection e divided by n of e. This is going to be 2 out of n of e is going to be 3. So that's 2 by 3. Alright. Let's look at the next one. P of e union f given g. Correct. So first we'll calculate e union f. Alright. See e union f. E union f is what now? 1, 2, 3, 5. And g is 2, 3, 4 and 5. Correct. So what is E union G intersection, sorry, E union F intersection G. So when you take the intersection, you get 2, 3, 5. Correct. Now we'll do the math. That is n of E union G, sorry, n of E union F intersection G divided by n of G. Correct. So this is going to give us this part of the question, which is going to give us, see, n of E union F intersection D is 3 by 4. So answer is 3 by 4. Fair enough. Let's do the next one. Look at this one. We have E intersection F. What is E intersection F? So E intersection F is nothing but 3. Now E intersection F intersection G, which is nothing but just 3 itself. Correct. So n of E intersection F given G, or sorry, P, probability. This is n of E intersection F intersection G by n of G. So this is going to be just 1 out of 4. So the answer is 1 by 4. Fair enough. So this is the answer for the last one. Now let's do the next one. Look at the third one. Assume that each child born is equally likely to be a boy or a girl. If a family has 2 children, what is the conditional probability that both are girls, given that the youngest is a girl, at least one is a girl, isn't it? So let's look at the math here. First, the sample space. Sample space is going to be 4. Correct? So 4 of them. So sample space is going to be either BB, BG, GB, and then GG. Isn't it? Equally likely. So conditional probability that both are girls, given that the youngest is a girl, isn't it? See, in this, let's say P of E is both of them are girls. Okay. Now, P of F is what? P of F is, so we have youngest to be a girl. So here we have BG and then we have GG. So, or it's supposed not P of E, I would say this is 1 out of 4 and this is going to be 1 out of 2. Because 2 out of 4 is 1 out of 2. Now, n of E intersection F is going to be just GG, isn't it? So, P of E given F is going to be, so we have 1 by 4 divided by 1 by 2. So, answer is going to be half. So, probability is half. Very simple. Let's do the next one. That is, at least one is a girl, right? See, for the second one, let's say this is another event H, assume it to be H. At least one is a girl, correct? So we can have a boy girl, girl boy, or a girl girl. At least one girl, so it can be boy or a girl. Now, E intersection H, sorry, not H, hold on. E intersection H is going to be just GG, correct? So what do we have now is that we need to look at the value. That is, n of E intersection H is going to be 1 out of 4 and n of H is equal to 3 out of 4, isn't it? So P of E given H is equal to 1 by 4 divided by 3 by 4, which is 1 by 3. So answer for this particular question is 1 by 3. Alright, let's do the next one. See this particular question? It's quite a simple one. Given that two numbers appearing on throwing two dice are different, find the probability that the sum of the numbers on the dice is 4. Now, guys, if you look at this, there are 36 possibilities, correct? Of which 1 comma 3 is one possibility, correct? 3 comma 1 is one more possibility, and 2 comma 2, of course, that is also a possibility, but we'll look into the case because they're saying two different numbers, isn't it? Now, these are the cases, but which of them will satisfy the condition? The satisfying condition part are only two of them, correct? So we can say that E intersection F, n of E intersection F is just 2 out of 36, which is 1 by 18. Now, n of F, n of F is what? That we need to calculate the like what when you throw the die, two numbers should be different, correct? So when two numbers are different, that's 36 minus 6. Except for 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Correct? So this is 30 out of 36, which is going to be 5 by 6. Make sense? So P of E given F is 1 by 18 by 5 by 6. So 3 times this is 1 by 15. So this is the answer for this particular question.